Okay, so we are getting into counting. We're actually, that's what this lesson's going to be on. You guys think you'll be okay for counting?
We'll see.
All right, so we'll start off. We'll be like, okay, so what is, like, how many ticks are there?
3.
You guys are going to ace this unit.
Oh, I don't know about that. Yeah.
All right, so
I can do it.
So, it gets a little tougher than that, right? But the idea here, like if we had, like suppose a particular restaurant, you have 3 choices for an appetizer. So you could get soup. Oop, the pen's not working. Nothing's working. Okay. So you could get soup, salad, or breadsticks. And 5 choices of a main. You could get hamburger, sandwich, quiche, fajita, pizza. If you're allowed to choose exactly one item from each category of your meal, how many different meal options do you have? Okay, so here's what we can do, right? We can actually just like list them out. So one way to solve this problem would be to systematically kind of list each possible meal, right? So you could have soup and a hamburger. You could have soup and fajita. And just make sure you get them all. And if you do that, you end up getting in total, well, how many different combinations are there?
50.
There's 15, right? So you could just count them all out. So there'd be 15 there. We're going to find better ways, right? Because you could probably see the problem with this method where you could miss one, right? There's like lots of ways that you can miss one. So you could do that, but once you start getting bigger numbers, it gets kind of tough. Solution 2, you can make a table. So you could have like soup, salad, and bread down the side because it's going to be one of those. And then you could have your other 5 across the top. And then you can see, well, if we did that, then like soup and a burger would be in that one. Salad and a burger would be in that one, right? So that's one. But you can see all the boxes that we have here would also add up to 15 with the different combinations that we had there. Okay. The other way would be something called like a tree diagram, where you could just say, okay, if I have a hamburger, then it could be these 3 options, a sandwich, these 3 options, and so on. But again, if you did that, you could see in the end how many different combinations we have of like a hamburger, soup, hamburger, salad. You'd have 15 in total, right? So these are just different ways you guys will see these, like maybe like in a diploma or something, these different methods. And it's called, these are all examples of like a sample space. So you can like write it out, just like brute force, just writing it out. We're going to find easier ways to do this though. Do you guys know what we could have done right off the bat? Just maybe thinking about this. We got 15, right? But in this example, how many different types were there? There was soup, salad, and breadsticks. So there was 3 for that first one. And then there was 5 choices for the other. 3 times 5, right? That's really what we're going with here. Yeah. So 3 times 5 is equal to 15 is what we did here. And you can kind of see that, right? 3 up and down times 5 across 15, right? Or 3 each of these, right, times 5 possibilities. 3 times 5 got us there, right? Either of those ways. So what this is called is the fundamental counting principle. It's a fancy name, but it really just means that if we want to figure out the number of ways that you can get, like with different combinations, we multiply those choices, right? So choice 1 times choice 2, or choice m times choice n, we just multiply those and those give you the total. Okay, so let's look at this one. So we'll do the try it now one. Suppose at a particular restaurant you have 8 choices for an appetizer, 11 choices for a main course, and 5 choices for dessert. If you're allowed to choose exactly one item from each category for your meal, how many different meal options do you have? So what do you guys think you'd do? You'd go all 3 of them, yeah. So there'd be 8 for the first choice, times 11 for the second choice, times 5 for the third choice. And I'm not sure what that is. 1 second. Is going to be 440 different choices there.
That's a lot of choices.
Yeah.
That's why I don't do first option.
Okay, now permutations. So I think we'll get into, I'll explain like what permutations are a little bit lower. I think we'll kind of develop what we mean by this. So if we did this, we say, okay, how many different ways can the letters of the word math be rearranged to form a 4-letter code word? Okay, so if we had like a code word, so 1, 2, 3, 4, and there's 4 letters. And I do this quite often. We make these like blanks and we fill them in. So you guys will be doing this a lot. And if you think about like our letters that we're able to choose from would be like an M, an A, a T, and an H, right? That spells math, but it could be like, in any order. It could be like M, T, A, and an H, right? Those are just the letters I can choose from, are all 4 of those. So let's make a code word, and in this situation though, we are not allowed to have repeating letters, right? So if I choose one letter, then I can't have another, or I can't have that for the second spot, right? So if that's the case, then in this first spot here, how many letters do I have to choose from? There's 4, right? It could be an M, a T, an A, or an H, right? So there's 4 different letters that could be. In the second spot, how many now? 3. That's the key point there, right? Because we chose one already. So if I say chose an M and put it in that, then the M no longer is there. So there's only 3 to choose from after I choose the first. How many do I have to choose from in the second or in the third spot? Yeah, only 2 are left. And then after that, how many in the last spot? 1. Okay, so we're starting to get in this idea of permutations, or what this is referred to in math. You got a new symbol. This would be written as 4 and this is called factorial in math. So an exclamation point in math means factorial. So if I had written let's say 5 factorial, that would just be 5 times 4 times 3 times 2 times 1, right, all the way down. Is that, you guys are good with that so far? Because we're going to use factorials here in a bit. Okay, so in general, this is the way that we write out a factorial. And I know that this looks confusing, but what this means is, here, I'll do it over here. What this means is that n factorial, so n would be any number now, right? So that could be like 10, 11, 20, like any number I put in for that one. And then, well here, let's actually put in a number. Let's say this was like 6 factorial. So we said that that was equal to 6 times 5 times 4 times 3 times 2 times 1, right? So if we look at our notation up top, that 6 factorial is equal to n, well that just is this, right? So that's 6 in my example. Okay, so that's our first one. And then this one is n minus 1. Well, that makes sense. In this case, that would be 6 minus 1 is 5. Yeah? In the next one would be n minus 2. That would be 6 minus 2 is 4. And then this part here goes ... 3 times 2 times 1. And what that means is that like ... like, okay, whatever the middle was, just ... And then we just know that it's going to end with a 1, right? Because that's what factorials do. They always end with 1, right? 3 times 2 times 1 is just how the whole thing's going to end. Yeah, you guys go with that? Because yeah, this notation will come up, so you'll just need to recognize that and know how to work with that. So let's do 6 just for a second. So it says, how many ways can 5 different door prizes be distributed among 5 people? Okay, so again, you could do blanks, right? So if you had 5 blanks, then you're like, okay, so in the first one, if I have 5 prizes, how many possibilities is there for that first one? 5. And then the second one, 4, 3, 2, and 1, right? And you multiply number of choices, right? Or number of options there to get your total. So 120. Oh, 120. Okay. Here, I'll skip through that one. And let's get to the idea. We're getting into permutations here now. So here, I'm going to give you guys... Yeah, let's do this one. So it says 8 sprinters have made it to the Olympic finals in the 100-meter race. In how many different ways can gold, silver, and bronze medals be awarded? Okay, so using the basic counting rule, there are 8 choices. There's 8 people, right? So you've got 8 people in total. And I'm going to do it this way too. I'm going to make my 3 blanks. And the first one would be like gold, silver, and bronze there, right? Yep.
Would it just be 8 times 3?
It won't be, no, it won't be 8 times 3. You got the right idea.
Oh, yeah.
This is going to be more what we were just doing there. So in this case, what this is going to be, let's just do the same thing. In the first spot there, so for gold, of the 8 people, you know, there's 8 people for this thing, how many different people could get gold? 8, right? There's 8 possibilities for that, right? Okay, you probably see where I'm going with this. In the second spot, how many possibilities are there now? 7, right? We chose someone for gold, so now there's only 7. And then for bronze? 6. This one didn't end, right? This time, that's it. We were just looking at gold, silver, and bronze. It was just those 3. So now we would just go 8 times 7 times 6, and that would be our answer. But we just kind of like got rid of the rest of it, the 5 times 4 times 3 times 2 times 1. The getting rid of the rest of it, part of it, is what a permutation is, right? So writing something out like this, like 8 times 7 times 6, is going to be it's called a permutation. Okay, so this is our general way to write a permutation. We're not going to use this one that often, but I want to kind of show you why this makes sense. So if we took in this example, we're using like 25, 24, 23 and going down like that. So in that example, if n was 25, right? So our n is 25 in this thing, and r is like the number of spots that we have there, then what that would be is 25 times 24 times 23. So if I'm writing it out this way though, this still makes sense, because this would be like 25 minus 1 is 24. 25 minus 2 is 23, right? So it's going down that way. And then the last one here, if you think about it, like this is just telling us how far we go. So last time it went all the way to the end, 3 times 2 times 1. This part here is saying, okay, it would be 25 minus 3, which is 22, plus 1 is 23. It's just saying that we end at 23. Okay? I know it probably seems like, why, who cares, or whatever, right? We'll get to a better one. This is just to kind of get us ready for permutations. Okay? And this is going to be, so it's NPR. So like subscript N like behind the P and then an R. All right? So what is happening here, and this, sorry, is on your formula sheet. So you guys have this one. So it'll always be there and ready for you. And I just want to explain what's going on with this one. So what we're after here. So let's do it with an example though. So it says I have 9 paintings and have room to display only 4 of them at any time on my wall. How many different ways could I do this? Okay, I'm going to do it the way we did it the first time and then show you that permutations are the same. So we've got 9 paintings and only 4 spots, right? So let's make 4 blanks. There's only 4 spots to choose from. So how many would I have in the first spot? 9. How many would I have in the second? 8, 7, 6. Multiply them together, and that's your answer. That's a perfectly fine way to do that question, right? Just to write the blanks, write them all in, multiply, right? But we also have to understand how permutations work, where this would be the same thing as writing. Okay, so let's write out this actual equation. So this would be NPR is equal to n factorial over n minus r factorial. Now let's actually just put some numbers in for this thing. So what this is, so NPR, n is the number we started with, right? So that would be 9. P, and then r is the number of blanks, the number of spots that we're like choosing. So what would that be? 4. Another way of saying this, what I kind of do in my head when I'm doing these questions, is this is like 9, pick 4. like 9p4. So it's like of the 9 people, we're going to pick 4 of them. Is a good way to remember it. So 9 pick 4 or 9p4 is equal to now n factorial. So that would be 9 factorial over, and then n minus r. So that would be 9 minus 4 factorial. Okay, let's just keep going with this. So I'm just going to write this out, but I'll actually call that 5. So this would be 9p4 is equal to 9 factorial over 5 factorial. And what this is, let's expand it. So by expand it, I mean we'll write these factorials, expand it all the way out. Okay, so this would be on the top 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And on the bottom, 5 factorial is 5 times 4 times 3 times 2 times 1. And watch what happens. You see all those 5s and 4, 3s and 2s and 1s and everything? They're the same on the top and the bottom. So they all cancel. So look what we got. 9 times 8 times 7 times 6.
So
The same thing that we did when you guys just put them in the blanks.
why did we do it the long way if we could have just done it this short?
Good question. So this way was kind of like the intuitive way, right? Where you could just do it in your head, right? You could like put that in and multiply it and get the answer. This is the way that like a computer would think, right? Like your calculator. So this is kind of like a better way for this is the way your calculator would do it, right? Where it's like, okay, the way I find this is by going 9 factorial divided by 5 factorial so that I can cancel out everything on the back end of this, right? It doesn't know when to stop. Like it's not very good at knowing when to stop for like a calculator. You as a human are better at that, right? So you can write it out like this, but we need to kind of understand what the calculator does too, and like how that works with factorial, with permutations as well. So you need to be able to go back and forth between these. We have to do both.
Okay.
But in the end, just look at what we did though. A permutation, so when I write down like NPR and this whole confusing thing, all that this was doing was starting with, so 9p4 was equal to 9 factorial, and then the bottom part was just 5 factorial in the end, which was just like, it was just getting rid of all the other blanks here. It was just leaving us with only those 4 spots to multiply it, right? Like that's all that equation is doing. That makes sense? Okay, next. Can you guys, while we're on this, grab your calculator? All right, so the way that we're going to do this on your calculators is you're going to hit the math button, and then you're going to go over, so click over to probability, and this is where a few of our things are going to be. So do you guys see NPR there?
Yeah.
So it's going to be that one. We're going to be using NCR in the next lesson. And then that symbol there is factorial. So you could also just type in like 9 factorial if you wanted to figure out what that was. But we're going to do NPR. Go enter. And mine being like the TI plus version, it actually just gives me those little blanks where I can just fill them in, like just the number on one side and number on the other side. If you have that, great. If you don't, then what you would have had to have done with the older one was type in like 3 and then go NPR. And then put the other number in. Like you have to go like number NPR and then the other number.
You have a pad that you can click around on now.
No, on this. This is like I got the TI-84. TI Inspire is the other style, and then TI Inspire I'll help you with that one after. We'll just kind of show you.
One working like a Inspire calculator because I'm looking at cadence and it's
Should be the same.
going to.
So here I'm going to go 9p4 and then enter, and that is 3024, which would be the same thing as 9 times 8 times 7 times 6. 3024, right? That's the same numbers doing the same thing. Okay? All right, let's do this one quick. So we'll do the try it now. So how many 5-character passwords can be made using the letters A through Z? And then this is very common. So yeah, very common type of question where they want to know if you guys understand the difference between if repetitions are allowed or repetitions are not allowed. So let's, how many 5-character passwords? So let's go 1, 2, 3, 4, 5 would be a good way to do this. And then how many letters are in the alphabet?
26.
Yeah, 26, right? There's 26 letters to choose from. Okay, so if repeats are allowed, what would it be? Well, how many would be in the first spot then? There would be 26. And then the key here is, if repetitions are allowed, how many in the second spot? 26. 26. 26. 26. And then fundamental counting principle, we just multiply a number of ways, right? So then we just multiply all of those. And another way of writing that, you'll also see this as 26 to the power of 5, right? Because there's 5 spots there. Be the same thing. So whatever that is,
130.
big number.
Just 100. Wait a minute.
And that, it's going to be a big number.
It should-
One
yeah, I did
one
it wrong, I
eight
did it
eight 1376.
Yeah, so big number, right?
wrong. I put it in wrong.
Yeah.
Yeah, we could tell.
iPhones.
All right, so now repetitions are not allowed. Okay, so this would be 26 times
25.
25 next, times 24, times 23, times 22.
7,893,600.
Okay, so that would be the right answer. So here, I'll do it too. So what would you say it was? It was 26. Here, I'll type it.
Okay.
All right, so we get, so a lot of different ways, right? Now, while we're doing that, let's just write this some different ways too, some other ways that we know how to write this. This would be the same thing as, well, 26, well here, we'll go NPR is equal to n factorial over n minus r factorial. So this would be, we could write this out again as, okay, what would the n be?
26.
Yeah, 26. So like of the 26, we are going to pick 5 spots. Yeah. Okay, so you could just type that, like just put that in your calculator and get the answer. But let's actually use the equation. That would be the same thing as 26 factorial over 26 minus 5 factorial, which is the same thing as 26 factorial over 21 factorial. Right? And this 21 factorial is just like canceling out all the left, or all the rest, and just leaving us with these 5 spots. Good? Okay.
How do you put that into